In my day job as a geotechnical engineer, I visit proposed building sites to conduct geotechnical investigations. This involves checking the geology of the area, logging subsurface materials to a certain depth based on the proposed structure and geotechnical standards, measuring the soil strength using various methods depending on the type of material, and collecting samples for lab testing. For any structure, whether it's a road pavement, bridge, or a building, the soil underneath the foundation must have enough strength to support the structure and minimize excessive settlements or failure due to loading. Pretty straightforward, right? But what about cases where the soil itself adds a destructive load to the structure? Have you ever wondered why homes and roads in certain areas develop cracks over time for no apparent reason? Well, the house that I grew up in did, and so did many others in my neighborhood. This issue is more common than you might think. My name is Chilo Chashe. I'm a geotechnical engineer, and today let's talk about reactive soils and structural foundations. Reactive clays, also known as expansive soils, are a type of a soil that undergoes significant volume changes with moisture variations. When these soils get wet, they expand, and when they dry out, they contract. This constant movement can exert tremendous pressure on the structure, leading to damage. Clays can be divided into two classes: residual clays, which are found in their place of origin and formed by weathering, and transported clays, also known as sedimentary clays, which are removed from their place of origin by erosion and deposited in a new location. So, what makes reactive clays so problematic? The main issue is their ability to expand and contract due to their microscopic structure. This movement can cause foundations to shift, walls to crack, floors to become uneven, and even plumbing systems to break. During wet seasons, for example, areas around the edges of the buildings are exposed to more moisture, causing them to expand first and create an uneven displacement. The reverse happens during the dry seasons, creating stresses on the building and utilities, leading to cracks and breaks. Some high-profile cases include the Sydney Opera House in Australia. The site is underlain by clay soils that expand and contract with moisture changes, leading to foundation movement and structural challenges. Another one is the Tower of London in England, which has also experienced cracks and structural issues over the centuries due to reactive clays. So, how do engineers determine the extent of soil reactivity and design appropriate foundations? Remember, in my introduction, I mentioned collecting soil samples for lab testing. If the site is underlain by clay materials, a shrink swell test is conducted to check the sensitivity of the soil. The initial moisture content of the soil sample is measured. Then the sample is split into two. One sample is soaked in water to hydrate, and the change in volume is measured. The other sample is dried, and the change in volume is measured and then recorded. The total volumetric strain is then used to calculate the shrink swell index, which is further used to classify the sensitivity of the site. Several measures can be implemented to mitigate the effects of reactive clays. For instance, increasing the depth of the foundation past the near-surface soils exposed to seasonal variations, or stripping off the near-surface reactive soil and replacing it with more competent fill material that is less reactive, then build the foundation on that. Let me know in the comment section below if you live in an area with reactive soils and what has been the impact on infrastructure. Please leave a like and subscribe to the channel. Thanks for watching.